Hello, Mr. Nabil. That's the assignment 3 that you asked for. So here is the task 1, the implementation of merge sort. For the recursive implementation, I followed the example that we did in class. So finding the mid index position, and then splitting the array in two, and recursively so calling the function again to separate the left and right kind of two subarrays to uh, search for what what we are looking for, and then combine them back. And for the interactive one, it was about the doubling the size of the array by interaction. So a loop inside another loop to uh, first of all finding one increasing the size of the array and the other one looking for the middle part. So and creating an array based on like starting from the left, reading orientation. So from left into mid, and then the other one for the right portion. So from mid to the end, but with a nested loop. And yeah, here's the logic for the mid orientation, and the other one is it's based on the find the end of the what would be the right array and merging them back together again. And that's the logic for merge. So I split it the two halves in like I start the logic to split the two halves in variables itself, create a temporary storage for it. So for loops to loop through them, but both at the same time. And here I got the highest numbers to be compared and use the array this one here to be used as a bridge to direct the numbers to its right place. So which would be order based. So lowest numbers compared to the highest one pushed to the left, and the highest ones compared to the highest uh, to the right. And this is for any remaining number that would be match or close to the highest number. And here's the testing. There you go. I wasn't sure if I was supposed to edit this or add more, so I just followed what you left for us. So for test two, which would be heap sort, so I did a little bit different than you explained to us in during class, because you gave us an example of a tree that starts with the lowest number, and this one it starts from the highest. I read about it that there's the max heap implementation. So you start the root is the highest number for now, and then it goes the tree grows from going like this from the highest number to the lowest. So yeah, that's the max heap find starting from the leaf and storing the highest number at the root. So yeah, there you go. Here's the implementation for the heap file, which would uh, keep switching the numbers until it gets to the right place and following a decreasing order in that case. And then for the swap to rearrange any of them at the end to make an increase account. So let me show you the implementation for it. So there you go, the original one, and then starting from the highest and then increasing account. And for the last one, it was the quick sort, which was I mean, the implementation was basic the same for any of this. So using a number at as a what do you call it, as a comparison. So the finding the pivot here and comparing the lowest to highest. So and make the changes between so it gets in the right order. This swap method stays the same because it's just a matter of repositioning and ordering back. So, but here I picked the pivot number and as a separated things to be just to serve as a comparison only. So okay, and then put it back as I wrote it down there. So let me show you the testing too. There you go, the original one, and then the increasing one. And yeah, that's pretty much it. I'm not sure if I was supposed to do something else, but thank you, Mr. Nabil again. So yeah,